Okay, good afternoon. I think we can get started. I hope everyone's been enjoying the talks today. My name is Timo Hokas. I was supposed to be co-presenting with Janne Heino, who's the lead architect for NESC, or the Nokia Private Cloud. Unfortunately, he wasn't able to attend it today, so I'll be going through the presentation and hope you'll be able to kind of attend one of Janne's later presentations on what we do and what sort of workloads we support. So just a couple of words on myself. I'm one of the founders of Kubernetes. We're a consultancy and a product company working on automated managed services. And a lot of work we've done has been together with Nokia. So I've been working with Nokia since 2011. I'll share a bit of the background on how the private cloud has grown on that side. And we're also a Sidero Labs implementation partner. And like I said, I hope you'll hear one of Janne's talks later on. So he's the lead architect, probably the single person responsible for getting or kind of growing the NESC Nokia private cloud. Maybe sharing a couple of words on our interactions. So we've been working long together. Typically when we had a proof of concept or a prototype or something in the morning, in the afternoon he had already sold it internally. So we kind of got into this agile cycle of developing stuff fairly quickly. The other kind of comment from his side was every single time we had a use case, I came up with a reason to have a new database or a new queue system or something in place. But we've worked on a lot of different use cases, from big data storage to kind of internal monitoring. And there is a reason why you might need a Cassandra or Kafka ELK, and these were like way back a long time ago. Nokia and NESC. So what is the Nokia private cloud? For those who don't know, it is one of the largest private clouds in the world, and there's three different aspects to it. So first of all, it's the kind of the internal private cloud, pretty much 100% open source. We've got a lot of users still on virtualization technology, so there's a lot of OpenStack, Zephyr storage. Kubernetes obviously has been growing dramatically. We try to use the same software stack also for NESC provided edge deployments. So keeping as much of the automation and tooling the same, whether it's used internally in large data centers or whether it gets shipped to a customer on-prem. And there's the third aspect, which is the hybrid cloud. So I think it was 2017 when we started the integrations with the hyperscalers, and we've now got full connectivity and automation in account setup and all the kind of landing zone related things with all the major cloud providers. Just a couple words on to understand the scale. So we're talking about over 900,000 virtual CPU cores, 7 data centers around the globe, over 6,000 projects. So these being mainly OpenStack related accounts. They could be for a single service, could be for a team. But again, it's still 100% open source. And well, I'll tell you a bit on kind of what it started from, but quite a few servers nowadays. So all of this kind of started with Janne having a calendar full of meetings, not really knowing why he was expected to go there. And as he said, well, he started not going to the meetings to see whether anyone would notice, and that didn't really happen. So they grabbed a couple of servers and kind of put it somewhere on the side and started experimenting with private cloud technology. and they were using eucalyptus. I'm not sure whether anyone's familiar with that. We happen to be using it internally, so kind of AWS API compatible sort of private cloud platform, which was used for the first years. And the early years were quite rough in a sense. The cloud was reinstalled possibly on a weekly basis. You might have to reboot everything. So I think many of the first users had a really rough time with us. But within a couple of years, we got some like proper end users. There was a lot of 4G development related use cases, for instance. And we had to really kind of step up to be able to keep it up and running, automate in a sensible way. So if you kind of look forwards to 2015, basic services, Ceph-based S3, EBS. We started experimenting with Kubernetes quite late, so 2017, 2018. But like with many things, when you kind of have something that is automated, it's easy to deploy, kind of starts growing very quickly. If we look more at the end of the time scale, and specifically kind of how we've been using Talos, we started with the bare metal trials around 2020, so quite early. And like we had for 2021, part of the work, like Nokia and Sidera Labs signed a contract for the official support. And what we did is ruin a bit of Talos. So obviously we had a lot of old non-modern use cases, requirements for CPU flags not available, 32-bit driver sort of things. So we had to tweak, and like we really thank the guys at Sidera Labs being able to kind of support us. And that's kind of what happened also with the additional use cases. So we've worked with them on GPU related things. We've worked with them to get the Palo Alto Prisma Defenders working with Talos, and kind of we're collaborating now to kind of add support for AMD and everything else that we need. So that basically means Talos has become like a foundational building block for us. Everything, like I'd say 98% of what we do nowadays is Kubernetes based. Talos is going to be kind of part of that stack. So we're building cloud using Talos, and obviously kind of what we aim for is doing something like this. But that's still kind of in the future, hopefully with Nokia and Talos collaborating. So I'll go over a couple of the different use cases on how we apply Talos and what are the services that are kind of built on top of that. So we started with what we call NKS, or the Nokia Kubernetes service. So like I said, we were a bit late on jumping on Talos. We had used we had looked at Core OS, we had looked at Mesos, we had looked at other alternatives. But when it was clear that Kubernetes is the way, kind of we went all in for it. And NKS is our internal managed Kubernetes. So here are a couple of numbers on the scale. Today, I think we're a bit over 200,000 CPU cores. We've got around somewhere between 400 and 500 production clusters that are managed through automation. I think the currently oldest production cluster that we have is nearly 5 years old. And on the size of the clusters, so some are small testing ones, don't really count those into the prod clusters. Others are fairly large. So it's 7K cores for a virtual type of cluster, built on top of OpenStack, and then around 12K or something for a bare metal cluster. And so far, still, I did a presentation last year. We hadn't lost the cluster. We still haven't lost the cluster, which is really good. On the NKS architecture, there's a couple of core services that we rely on. So we use Netbox for server and network-related inventory. For the virtualized environment, obviously OpenStack is the kind of platform that we use. Ceph for storage, Vault, HashiCorp Vault for secret storage, and DNS. So these are kind of external things that we use when creating the service. Then we have a Talos-based NKS management cluster, where we have our own NKS API, providing kind of the user-facing interface and API for cluster lifecycle. And then, which is kind of manages both the virtual and the bare metal clusters. For bare metal specific clusters, we've got an additional, we're talking about NKS-V, which is NKS virtual, NKS-M, which is NKS metal. So we've got metal specific additional APIs. So for instance, SDN related networking. We've got a resource manager that takes care of how servers are being allocated and used in clusters. And we're using Cluster API and Sidero Metal for the provisioning side there. What NKS does is creates these customer clusters. So they are single tenant. It could be a single team. It could be like a product, but they have their own environment. So we're not doing huge multi-tenant clusters. They get their cluster, which is fairly standard out-of-the-box Kubernetes, with additional pre-enabled integrations, for instance, for integrating monitoring and log shipping, which gets shipped into these per data center NKS monitoring clusters. And we've got also some custom controllers that we run inside these clusters, mainly for the reason that sometimes it's easier when you have a view from inside the cluster and also from the outside. So especially with older versions of OpenStack, you might run into certain problematic scenarios, and it's easier to kind of diagnose the situation from both sides. On the metal side, one of the things we did, we went with pure L3 routing. So we brought the intelligence to the actual nodes. We're running FRR. This gives us the flexibility of kind of defining, having a huge server pool in racks and building the clusters as needed. At this scale, we typically were adding like full racks when we expand capacity. But especially with AI ML and like GPUs, won't be available in the same sort of way. So this gives us the flexibility to extend someone's cluster, for instance, by a third of a rack, or add a certain amount of nodes with GPUs connected to an existing cluster. Talking about some of the things, or kind of lessons learned and everyday problems. So obviously there is a shared responsibility between us and the end customers. So we manage the infrastructure. We make sure that if something breaks, that we kind of rebuild it. We make sure that the kind of the cluster is available, and they manage the workloads. Some of the workloads obviously are not fully cloud native, and we need to look at what's the best way to kind of manage upgrades. Some of them are users are also running like really long-term batch processes, so it's processing can take days, if not weeks. And some have fairly different kind of high peak, low peak sort of activity in the clusters. So one of the things that we added was the support for this sort of intelligent upgrade, which gives the end user the opportunity to kind of understand when the upgrade is happening and also kind of participate into the cycle of what's going on. And The way it started was something as simple as this. So the end user can create like an upgrade specific configuration in their cluster. They can define a certain type of job that gets run, like a pre-hook and post-hook, whether it's kind of inlined or whether you get it kind of, you do a call to a URL. And then you can define specific overrides for certain nodes or node groups on when the upgrade can happen or if there is a node that is blacklisted. So we can start with the upgrade and the customer gets to kind of participate on how it happens. So we start with the control plane upgrade, and that always goes first, and the users don't need to participate. But kind of after that, we have a look on whether the node is upgraded, is it blacklisted, are we within the duration that we can start the upgrade, and then they have the options of using the pre and post hooks before the upgrade happens on specific nodes. Moving on to the edge. So I think edge is, it's not really clear on what's meant. There's a lot of different interpretations on what different people consider edge. So is it a Raspberry? Is it a single server? Is it a specific sort of this form factor? Is it a full AWS outpost? In our use cases, typically it's a single or two racks of hardware being kind of the edge deployment. And like I mentioned, we try to use the same sort of tooling and infra that everyone's used to on the private cloud side. So that means Kubernetes and OpenStack, storage delivered by Ceph. In some cases, the only end user workload we give the option for is Kubernetes. So we don't push for the VMs if they're not really needed. And officially, in addition to kind of what we normally would provide, obviously we need to add some specific extra services. So container registry needs to be shipped, secret storage needs to be available. If we manage the full end-to-end, there might be like a traffic management layer, and obviously monitoring and logging related services. A very quick call for hands. How many of you have worked with edge sort of deployments? Okay. I was going to hopefully ask, did you think it was easy? A little of a loaded question, because from our experiences, it's not always that easy. Sometimes it feels that it's a lot easier to automate 200,000 CPUs locally than do like a single rack on the customer side. So some of the examples of the things that you will run into, and these are very obviously customer and deployment dependent. So what's the connectivity that you have from there? Is it air-gapped? Do you have full internet connectivity, or is it partial, which is always kind of the tough case, because then you need to kind of experiment what's possible or whether you just kind of expect it to be air-gapped and kind of forget about the connectivity that might work. For monitoring and logging, do you kind of store it locally or do you ship it out? What's the targeted update cycle that you can support? In some cases, it might be like once a year, once a half a year. Ideally, we would like to sync it with the upgrades that we do internally with all the other environments, where we do kind of gradual deployments on a daily basis. Limited managed service availability. So we're used to having dynamic DNS. We're used to having database as a service. Obviously, these don't exist. And also kind of complexities on what's the backup hardware? Is it available? How long will it take to kind of get sorted? So I think this is one of the cases where the industry still hasn't found the optimal way of managing it. There's quite a lot of complexity, so we're early on how to deliver these sort of deployments. Talking about OpenStack, so I mentioned around 900,000 CPUs compute totally. We've got over 200 now on, or 200K now on Kubernetes. The rest is mostly VM based. We also have like a bare metal as a service sort of solution, but that's small. But there were a couple of reasons why we need to kind of move from the old solution. So the old way of running OpenStack was the traditional. You've got the bare metal, you've got traditional OS. We were using CentOS, and we had native deployment of OpenStack on top of that. We were also kind of adding capacity one rack at a time, which for most time is okay at large scale, but like I gave the example with the GPUs and specific sort of workloads, we would like to have the flexibility of doing it per server if needed. We also were lagging behind a little on kind of what the OpenStack we were using could support on the GPU side and Windows side, and some kind of internal process related, not kind of technology related things. And we thought a good way forward would be to kind of flip it over, put Kubernetes there. So that is kind of what we were doing proof of concepts last year, and what's kind of being built this year and deployed at large scale, hopefully next year. So we're going to have a Talos-based layer, Kubernetes, where we run OpenStack on top. And this is going to kind of replace the current OpenStack environments that we have. Then moving on to AI. So we had managed Kubernetes, we had the edge deployments, we've got the OpenStack. I'm sure you can kind of guess what's going to be underneath for the ML part. So just to give a little scope, there are a number of AI ML platforms within Nokia, many running on top of the NESC cloud, some being on kind of lab type of environments. But most of these are using same sort of or similar sort of open source based tooling for the workloads. So we, for instance, heavily use Airflow for DAG orchestration. Ray is one of the very interesting ones, especially if you look at the kind of the GPU resource availability sort of thing. So you never will have all the GPUs that you want. They cost a lot. You won't get. There's going to be delays with that. So it's key to kind of use all the capacity that you have available in a sensible way. So it doesn't make sense to have a GPU allocated to a team who's not doing anything with it. So Ray is one of the ways where we can kind of slice the capacity, deliver it to teams in a sensible way. And many of the teams that had requirements for AI ML sort of approaches started with, yes, we absolutely need a bare metal machine, or it could be we need a very high spec VM where we're going to be running on. But the trend definitely is that when everyone starts looking at the actual production deployments, the production deployments are going to be on Kubernetes. The tooling is there, the kind of the flexibility is there. So that's kind of where pretty much everyone is going. A couple of examples on the use cases. So obviously there's a lot of Nokia product and service related use cases. 5G, 6G development, providing services for telco operators and kind of looking at the data on, for instance, on the network side. And there's quite a few also running private LLMs. I'm going to talk a little about what we do internally. So obviously, running the private cloud, there's a huge amount of data we have available. Log data from OpenStack, from Ceph, all the other services. The similar way, a huge amount of metric data on what these services are producing. So some of the examples are on forecasting, looking at the compute and storage, how we see, what sort of trends we see there. Anomaly detection, trying to identify what's wrong in an automated matter, and also kind of security. Example 1, anomaly detection in OpenStack metrics. So we're looking at OpenStack service specific values. We're having a two-way approach on first starting with an unsupervised model on reading the data in. But obviously to be able to improve, we're kind of then adding a second layer and doing supervised learning. So the initial model identifies the potential anomalies, and we then have a tool for the operational people to kind of look at what actually happened at the time and then do labeling on the data. And then this is fed into a secondary model which is supervised and using the labeled data, and we kind of compare the two. The other example is on the anomaly detection. So obviously a huge private cloud, a lot of traffic and no sensible way of manually looking at kind of what sort of attacks or what sort of things might be going on. So kind of taking that data from a few different points and feeding that into a model and identifying kind of potential attackers on based on the type of access they use for the services, how many ports do they access, and so on. So I mentioned the two, so isolation forest and random forest are the key ones at the moment being used for, but there's quite a few other use cases being developed also. And I guess the question, why do we think Talos works for us? And why do we actually really like Talos, and how does it fit? So I think most of these are familiar to all of you. Security in design. It's minimal. There isn't kind of a lot of extra things going on. The immutability, no SSH. There's a lot of kind of key things that make it unique and make it work. Being kind of config and API driven, it's been very easy for us to automate at this scale and make sure that the clusters come up in a expected way. And we've been an early user of Sidero Metal for the bare metal service. So that's worked really well for us on being able to support bare metal. And we find it very stable, very reliable. So that's kind of one, many different sort of aspects but they've kind of really well fit into the way that we build services. And we want to make the underlying layer as stable, as expectable as possible. And we've had very good interactions with the Sidero team. Like I mentioned on the different GPU-related use cases, the other sort of things when we need to do fixes, when we need to do the tweaks, Sidero has been kind of there collaborating from day one. So I definitely would recommend you give it a try if you haven't yet. Any questions on the content here? Did we have a mic?
Hi. It's working? Yes. Yeah. Have you already started to implement OpenStack on top of Talos and Kubernetes? Yes.
Yes.
What are your results?
Sorry, what are
the results? How is it working, and what's the difference between running OpenStack directly on bare metal?
Are you talking specifically about performance related, or kind of what aspect of it?
The one you want to talk to us,
Sure,
the one you prefer.
Yeah. So like I said, we did the prototyping last year. We've gone through all the major use cases and kind of how they fit in. And we're actively developing it. So we'll have the first kind of production environments for specific target users by the end of the year. And kind of the long-term rollout is planned starting next year going on, because obviously we need to replace a lot of the environments. We don't have the full performance figures yet, mainly due to, even at this scale, the testing hardware and dev hardware that we're building on is not the identical compared to the production hardware. But that's something that's planned very soon. And it's going to be very interesting to see kind of how it compares. But just from the kind of the operational point of view on how to deploy new versions of OpenStack, how to kind of add redundancy, make it reliable. There's so many things that Kubernetes makes easier on that level. So we definitely kind of think well, we are planning at replacing everything that we currently have with this new approach. Was there...
And similar question. Have you tried KubeVirt on Kubernetes to run VMs, or just OpenStack because you've been using OpenStack already?
Yeah, we have experimented with it, and it's a good question. So I think for us it boils down to we have a huge user base that's used OpenStack for a long time, and there are things that OpenStack kind of provides over what KubeVirt at the moment does. For certain environments, KubeVirt definitely might make sense. And we're going to look at kind of specific smaller environments. But at the moment, what we need to support within that environment is VMs and the OpenStack APIs and Kubernetes. So that's kind of the larger sort of rollout. But I think it's definitely interesting to see kind of what direction KubeVirt is going. And as the amount of VMs is going to be decreasing, my guess, it can probably fit many of the kind of the use cases better going forwards. So as you have a smaller installed base of VMs or requirements for VMs, then definitely.
And regarding Ceph, you've been running only on OpenStack, or you tried it also on Talos, basically on Kubernetes?
Sorry, Ceph?
Ceph, I mean, is it running only on OpenStack?
Ceph currently is running on bare metal. We've got the plans to kind of move that onto Kubernetes also. And obviously, like what was mentioned in the earlier presentations, Rook, and there are a number of options depending on the sizing. But from our point of view, as the deployments typically are larger, either on-prem or our private cloud, or the edge deployments that we do are kind of sizable in being a number of racks, then kind of having bare metal Ceph at the moment still makes sense. But I do expect it to be moving towards being Kubernetes based also.
In the end of your talk, you just mentioned that you think Talos is rather stable. So on what kind of data are you actually drawing this conclusion from? Because you have not been in production yet. Have you had real update scenarios? And how stable do you think it is? Because, I mean, we heard from another talk there are sometimes actual problems. And how did you experience some? And if so, how did you overcome them?
Yeah, we've had Talos in production on bare metal since 21, I think. So we have been running it there. And very soon after that, we also added support on the virtual side. So we support both virtualized Kubernetes and bare metal Kubernetes. And what we had on the platform initially was a support for multiple Kubernetes provisioners. So we had a look at Anthos, we had a look at OpenShift, we had a look on, we were using RKE1, for instance. For the last couple of years, the default has been Talos for all the clusters. And we kind of compared to the other options on the provisioning level or kind of stable running, we're very happy with Talos. Okay, great. Thanks, everyone. It was nice sharing this with you. If you have any questions, feel free to ask me later. We've also got Jaakko here, who's our NKS Jaakko tech lead, so he can also answer more specific questions if you're interested. Cool.